Hi, my name is Derrick Carr, and today I'm going to be presenting my research, which is titled Tracing the Evolution of Nuggets in the Nearby Universe. So we start off with red nuggets. They were first discovered in the late 2000s, and they were pretty confusing upon discovery because they were really compact, much more compact than other galaxies of a similar mass. We know that cold colliding gas can cause loss of angular momentum and thus contraction of the galaxy, but red nuggets are really gas poor, meaning they don't have a lot of gas, and they're not star forming as a result of not having gas fuel. So it wasn't up until around 2013 where we finally got an idea of how these galaxies came about. The process is that we first take a galaxy and have it collide with a lot of gas. The gas then falls to the galaxy's core and starts forming stars, including bright blue stars. And eventually, after reaching a key mass, the gas will run out and blue stars will die, leaving just the red stars. So the conclusion is that red nuggets must have been blue nuggets at some point in time. With that said, this evolutionary track may differ in the early universe than in today's universe. In the early universe, it might look something like this. Start off with a dwarf galaxy, have it collide with a lot of gas, get a blue nugget. And then once it passes that key mass, it will turn into a red nugget. And then over cosmic time, it will puff up into a massive elliptical. You can see right here. In today's universe, it starts off similarly with a dwarf galaxy, gas colliding, turning into a blue nugget. But as it passes the key mass threshold, we may find that it evolves into a red nugget, or it is possible that it may regrow a star-forming disk and turn into a star-forming disk galaxy. And additionally, we've also seen evidence of disky red nuggets as well. With that said, our goal is to explore how nuggets in today's universe form and evolve and see how they differ from nuggets in the early universe. With that said, since nuggets in the early universe look different than nuggets in today's universe, we have to make a selection criteria for nuggets in today's universe. Here's what we decided on. First, we want these nuggets to be isolated. And the reason why is because if you have a galaxy in the group, it is possible to have a galaxy look like a nugget, but really is not, and looks like a nugget only because of galaxy group physics. So therefore, we only want to choose isolated galaxies. Nuggets we know are also very small, so we want to make sure that we have small galaxies as well. And on top of that, they're very compact, so we want to choose against large diffuse galaxies. Finally, we know that nuggets have a dense core due to the way that they form. So we want to make sure that the galaxies we choose have dense cores as well. With that said, we found 84 nuggets in our nearby galaxy survey. And here are some of the results. On the x-axis, we have the log sum of the stellar mass and the gas mass. On the y-axis, we have a color scale where a higher number means redder and a lower number means bluer. And the contours in the back are with respect to all the galaxies in the parent galaxy survey that we're looking at. And the images are the nuggets that we picked out in that survey. So common sense check, we can see that the lower down nuggets are bluer and the higher up ones are redder. So that's good. We can also see that as galaxies pass this key mass, blue nuggets in particular really start to move up towards the red nugget area, as we'd expect. Additionally, further investigation into the nuggets, we find that blue nuggets are gas dominated and are forming lots of stars, while red nuggets are gas poor and are hardly forming any stars. This also agrees with expectations. So with that said, some of our next steps are to really look into the evolutionary mechanisms of nuggets. For example, what mechanisms expel gas within a nugget? Do blue nuggets actually still evolve into red nuggets, or are they more likely to evolve into diskier objects? And also, we want to see what simulations think nuggets look like in today's universe as well. For example, I'm using one simulation called Illustrious TNG to pick out blue nuggets and then run them forward in time to see what they look like later. This simulation looks very promising and has very realistic galaxy physics, so I'm excited for the results. Thank you.